Hello everyone, today I'm going to present about my research with the title of Correlation of Tongue soft tissue and dentofacial deformities in retrognathism and prognathism, a comparative cephalometric study. My name is Nattavee Wangpiriyapanish. I'm the student of master degree from Oral and Maxillofacial Surgery, Faculty of Dentistry, Chulalongkorn University. The outline for today consists of 4 parts as following. Let's start with the introduction. As we know that tongue is one of the important organs of our body, the main functions of tongue are chewing, swallowing, tasting, and vocalization. Tongue is sensitive, kept moist by saliva, and richly supplied with nerves and blood vessels. It serves as a natural means of cleansing the teeth, and it's also important oral structure that affects speech, the position of teeth, individual social activity, and breathing. Moreover, tongue posture also has a great significance on dentofacial deformities and the development of craniofacial structures. Many previous studies have revealed the correlation between tongue and craniofacial morphology. However, a multivariate evaluation of the correlation between tongue soft tissue and dentofacial deformity has not been clear. This study intends to document the relationship between tongue parameters and craniofacial skeletal in adults with retrognathism and prognathism. So the objective of this study is to evaluate the tongue soft tissue that affect to dentofacial deformities in skeletal class 2 group and skeletal class 3 group. Next one are the materials and methods. This study is a retrospective study which was conducted on lateral cephalogram of 140 patients who enrolled in oral and maxillofacial department for orthodontic surgery at the period of times as following. The inclusion criteria were age older than 18 years old and were diagnosed with mandibular prognathism or retrognathism. All individuals have no history of previous oral myotherapy or tongue exercise, no history of splenectomy or tongue surgery, and also no associated syndrome. The skeletal classification was determined based on the A and B angle. Skeletal class 2 was defined by A and B angle more than 4 degrees. Skeletal class 3 was defined by A and B angle less than 0 degrees, and there were 70 samples per each group. The selected films were saved and printed on A4 papers. Then the tracing process went on by using assisted papers. A single investigator performed all the tracing, and the reliability was also evaluated. The cephalometric analysis consists of 2 parts, which are sagittal and tongue measurements. Sagittal measurements compose of 4 variables, which are SNA angle, SNB angle, ANB angle, and mandibular body length. And tongue measurement composed of 4 variables, which are tongue length, tongue height oil, and tip of tongue position, as the label in the figure. The reliability was measured by the inter-class correlation coefficient. The Kolmogorov-Smirnov test was used to access the data normality. The continuous data was summarized as mean plus minus standard deviation. The tongue soft tissue parameter of skeletal class 2 and class 3 were compared by the Mann-Whitney test, and the relationship of tongue soft tissue and skeletal cephalometric variable were assessed by Pearson correlation coefficient. A value of P less than 0.05 was considered as statistically significant. Oops.
ไม่เอาอีกไม่เอาอีก
เอาทำไม
จะเลือกสไลด์ไหมใช่
Okay, so sorry. And the last one is the result and discussion. This is the example of cephalometric tracing into skeletal patterns. The picture A is for skeletal class 2 and picture B for skeletal class 3. The inter-class correlation coefficients for inter-rater reliability range greater than 0.9 for all variables, indicating the excellent reliability of the measurements. The total subjects were 59 male and 81 female, and there was no gender difference between skeletal class 2 and class 3 groups. The age of sample ranged from 18 to 58 years. The A and B angle of skeletal class 2 and class 3 were significantly different. The majority of tongue variables, which were tongue length, tongue height oil, were significantly greater in skeletal class 2 than class 3 group. The tongue tip position in skeletal class 2 was also higher, but there was no significantly difference. Although the value of tongue analysis in skeletal class 2 was more than class 3 group, the ratio of tongue length and tongue height were approximately the same. The result revealed a constant of tongue length and tongue height ratio in both skeletal groups. The majority of tongue variable and A and B angle had a significant correlation, which represent a relationship between tongue soft tissue and type of skeletal classification. Moreover, all tongue variables were correlated among themselves in both skeletal groups, especially tongue length and tongue height oil that had a relationship in strong level. The discussion. From Moss and Salengin's study, the growth of soft tissue has a substantial impact on the skeletal growth. The cephalometric analysis enabled the inspection of the skeletal deformity as well as soft tissue structure. A lateral cephalogram is a two-dimensional analysis, which is simple, non-invasive, and inexpensive. It is widely used for investigation and provide reliable information on craniofacial skeletal with less radiation than a three-dimensional analysis. Our results seem to support some previous studies, such as Low et al. In 1985, Yoon et al. In 2017, and also Tuskik et al. In 2008. On the other hand, our findings were in contrast to some studies such as Fatima and Fida in 2019 that found no association between resting tongue posture and skeletal classification. However, these results variation may be related to the different methodologies. The mean value of tongue variable in skeletal class 3 was supposed to be higher than skeletal class 2 as the pathogenesis of skeletal class 3 seemed to have more oversized tongue. Some previous study reported that tongue length and tongue volume in skeletal class 3 was greater than skeletal class 2. Subjects with skeletal class 3 tend to have tongue tie, and it could limit tongue in lower position. According to my study, measurement of tongue soft tissue was done in two-dimensional evaluation, so tongue tie could cause the restriction of the tongue and make the tongue length short in the cephalogram. So the comparison of volume or other parameter of the tongue should have been investigated in three-dimensional evaluation. The limitation of this study is the absence of the control group due to the lack of healthy individuals who undertake lateral cephalograms. In addition, although the cephalometric radiograph was appropriately accurate, a two-dimensional radiograph alone may not give a complete representation of a three-dimensional of the tongue. For further study, the norm of all tongue variable in orthognathic patients should be added to be compared with the abnormality of the deformity groups. Also, the volumetric three-dimensional analysis are necessary to provide conclusive pieces of evidence for an imbalance of tongue occupied space in the oral cavities. The conclusion, this study showed the relationship between tongue soft tissue and skeletal structures. All tongue variables have a significantly greater in retrognathism, and tongue soft tissue in the cephalogram presented a constant of tongue length and tongue height ratio among skeletal groups. Thank you for your attention. So sorry for the mistakes.
You said that when you do the experimental, why you have to print film on the paper, why don't you use the original film?
Because this study is a retrospective study, so it has to trace back to get the film at the past. So I have to save from the computer and print it in the paper, but it passed the process that calculate the same portion of the original film. So the printed film on the paper and the original film was the same portion.
I have one question. Why don't you use 3D image instead of 2D to measure the soft tissue in your study?
The same reason is that it is the retrospective study, and we only have a cephalometric radiograph of patients that have to get the orthognathic surgery, and not many people that take the CT scan or 3D analysis at the first time they go to the dentist. So I get only the 2D image. And maybe 3D image can be the further study to compare if it's agree or not.
Any more questions from the audience? Okay, so now it's going to be my questions. Well, because you use both raised positions and CO positions, do you think both positions have effects on tongue position?
In my opinion, I think I get the lateral cephalogram from, I think it has a standard position to be taken, so maybe the tongue didn't affect to the soft tissue.
Actually, there's a previous studies have been shown that the tongue positions of CO and rest position from class 2 malocclusions is not different, but because you do both class 2 and class 3 positions, so I think this is a little bit blind spot that you might have to test before if CO and CR is the same. And because when the standard procedure of the cephalometric, what the difference from the rest position, do you know what the difference?
I think I have no idea about it. So
All
sorry.
right. That's okay. Well, for the educations, as the radiologist, I will explain a little about this, because CO and rest position actually is different. Because rest positions they use in their surgery, orthognathic surgery, they want people to relax. That's why you say M, right? But the M is like a rest lip position, which is different position for regular conventional cephalometric. That's why I'm asking you this question. All right. Okay. Well, the other thing that I want to ask is that how do you know where was the tongue tip?
Actually, it's quite hard to define because it's the soft tissue structure in the film. but I think maybe I can see the tongue tip position.
But you already did your experiment, right?
Yeah,
Anyone else want to help her answer?
I think maybe I can see like a shadow in the film, but
I saw many people in the groups. Anyone else want to help her answer? Okay. Let's see this way. What the difference between the tongue position or the tongue tip position between your study and other study? What you did different from them, and why, and how you fix it? Okay. Can you catch my answer? I mean, my questions. Can you catch it?
I think yes.
Okay.
I measure from, but I don't know if I answer the right one that you want. But the tongue tip position I measure from the tongue tip to the SN line minus 7 degrees.
You mean you estimate the tongue tip position by make it perpendicular to the SN minus 7 degree? And
yes.
Okay, so
Because they have the previous study do like that the same.
but okay, if you say so, well, and then when you perpendicular lined up, where is the end point?
The I don't know how to explain
Okay, that's fine. But I can see that your interclass correlations is quite the same. It means you did some, whatever you did it repeatedly. So I think it might be good enough for the result. But anyway, can you answer me what another method to see tongue tip in cephalometric in other study? Do you know other method? Because actually, you know, soft tissue shadows in cephalometric is not quite clear,
Yes.
and it's very difficult to trace.
Yes.
So do you know what other study did to make it clear? And because of what I can see that your tongue lens position is also different from other study.
Yes. You mean do you mean that in my study class 2 is have more tongue length than class 3, right? But
no. I'm asking in other study, how they see the tongue tip? What they did different from your study? You use an S minus 7 degree,
Yes.
right? And perpendicular, drag the line down, and you think that's a tongue tip, which is estimation, right? But actual tongue tip is different. So the others study also do axial tongue tip with different method. Do you know that method?
No.
Okay,
Okay.
that's just okay. Well, this is gonna be a little knowledge, okay? Other studies, maybe you can include in the discussion later. Other study, they use barium sulfate to coat in the tongue, but that gonna be study that they do like before taking the radiograph. So I know that your study also have limited from you use a retrospective and so many film that already taken. So this might be the disadvantage that they have to discuss in their discussion. Okay, thank you anyway for all the nice slices and thank you so much to join this meeting.
So sorry, I'm so excited. But I actually remind that this tongue coded I read past before, but
Yes.
I'm so excited, but so I cannot think
Yeah.
about it.
Yeah, so
So
please,
sorry.
in the further study or maybe in the future publications, if you put that reference in the parts of discussion will be better.
Yeah,
Okay,
have
because I
seen
didn't see that paper yet.
Thank you.
All right,
Thank you
thank
so
you
much
so
for
much.
your good suggestions.